Hey, D. Dykstra here with another great math video. Today we are talking about rational functions. We're going to go through all the steps, we're going to draw it, we're going to show you the different pieces that we have. Now, when we're dealing with a rational function, you're right, we are dealing with a ratio. We have f of x is equal to a times x to some nth power. Then we have some denominator, that's b times x to some mth power. M is in math. Yes. And so we have that situation. Now a vertical asymptote will show up when we set the denominator equal to 0. And once we do that, we can solve for x. Vertical asymptotes they're shown by 2 vertical or 3 or however many you have, might only be 1, where the denominator is 0 and so the function is undefined. There was a little trick we used to have. It's still true today, and one is that if you have a number over a 0, that spells no, right? And that is undefined. Undefined. Now, if there's a 0 over some number, that's okay, right? That's just 0, so that is 0, so that is okay. So we're all good in those situations. So what you're looking for is where is the 0 in the denominator? Hence, that's why we set the denominator equal to 0. We have to solve for x, and we show that with vertical lines, dashed lines. Okay. There's another part to this that is the horizontal asymptote. So if we look at the rules right here for horizontal asymptotes, there are 3 basic rules. And there's a lot more we can get into this with limits and so forth, but I'll let your calculus teacher, or later in this class we'll talk more about that. But n is less than m, meaning the value of the numerator exponent is n, and the value of the denominator exponent, that leading term, the leading exponents, are n and m, where numerator and n is in the denominator. So if n is less than m, then that means we have a horizontal asymptote at y equals 0. If the n value in the numerator is equal to the m value, then we have a horizontal asymptote at the ratio of a over b. Okay, we'll have a horizontal line at a over b. These are the leading coefficients, right? We saw that in the beginning. A is the leading coefficient of the numerator. B is the leading coefficient of the denominator. Then, the last case is if n is greater than m, there is no horizontal asymptote, and we get a slant asymptote. All right, so those are the 3 basic rules for finding a horizontal asymptote. So what we're going to do now is I have this function, 3x squared over negative x squared minus 4. So but step by step, what we're going to do is we're going to find out how do we graph this rational function. All right, so first thing again is we need to set the denominator equal to 0. In doing so, I want to factor it, and we look at x squared minus 4, and I notice that x squared minus 4 can be factored into x plus 2 and x minus 2. Okay, so x plus 2 and x minus 2 were my 2 factors, and if I set those equal to 0, then I will notice that at x equal negative 2, right, x equal negative 2, and at x equal positive 2, I will make dashed lines, and those are my vertical asymptotes, and I will label them as such. Vertical asymptote at x equal 2, vertical asymptote at x equal negative 2. And I want to label that, so whoever I'm writing this for, doing this for, knows that's what I have. And they came from right here. All right. The next piece of information, I'll extend this up a little bit, is we want to know where is the horizontal asymptote. The horizontal asymptote, again, was according to these 3 rules. Over here, we have n was equal to, or n was less than m, n is equal to m, or n is greater than m. In our case over here, we have x squared over x squared. So in our case, n squared is n. This is our n value right here, n. And then our m value is this, our m value right there. So that is m. 2 is equal to 2, right? That makes sense. So we will have a horizontal asymptote at y equal the ratio. Well, the ratio is 3 over 1, right? There's an understood 1 right here. So at 1, 2, 3, we will have a horizontal asymptote. So I'll label it HA, y equal 3. Okay? I have my horizontal asymptote at y equal 3. All right. Now, we need to figure out what does this graph do in some certain places. So what I'm going to do is I'm going to erase a little bit of this information here so we can then move forward with graphing the function. So I'll just erase that real quick. And now what we need to do is graph it. And in doing so, all you're going to choose are points to the right of the vertical asymptote, in the middle of the vertical asymptotes, and then to the left. Okay? So a couple easy points. If you notice, this is squared and 3x squared. So I'm going to choose 4 as a number. I could go to 3, but I just have a feeling 4 is going to work out better. So f of 4, if I plug that in, that's 4 squared times 3 is 48, and then 4 squared is 16, minus 4 is 12, so 48 divided by 12 is the quantity 4. So at 4, I'm going to be at point at 4. And what you'll notice is you only really need one point in these sections because they're all going to have similar behavior. And that is, they're going to stay mainly in their quadrants, and they will hug the vertical and the horizontal asymptote in those areas. Now, I'll go to the middle section. And what's an easy number to choose in here? Well, there's 1, and there's 2, and 3. So I'm going to choose 0. So f of 0. Well, f of 0, if I put 0 here for x squared, that's going to make that 0. And we go back to our rule of 0 over some number is just 0. So that whole thing will be 0. And if I wanted to, I could just check at positive 1 to see if is this thing going down? Most likely it's not going to go up. So I have a feeling it's going to go through here. But I could find out 1 is 3 and negative 4. So at negative 3/4 is the value there. So I know this thing will come here. And I'm pretty confident it'll go like this. And so we'll get some shape like that. All right, now, the next thing I can do is go to the left side, right? The left side. And we see that, oh, let's go to negative 4. So now I want to find negative 4, f of negative 4. And since these are squared, right, this is negative 4 squared and negative 4 squared, which means it's just going to be a positive value. So we'll get the same value here as we did before. So this is also equal to 4. So at negative 4, that's 4. And we notice that it does the same behavior here as the other side. And that's basically what our graph would look like. All right, so we've shown that we can graph rational functions by looking at the vertical asymptote first, identifying where those vertical asymptotes are. Then we identify the horizontal asymptote using those 3 rules. Okay? And then once we do that, we put those basic lines in, vertical and horizontal, and then we just choose points, right side, middle, and left side of those vertical asymptotes and see where the function lies. And given those, the basic curvature there we'll normally get. All right? Anyway, thank you very much. It's been another great video. Have fun. Peace out. D Dykstra out.